I'm going to show you today a little tool that is very useful, and I would suggest that you get in the habit of using it and trying to work through it, and use it as often as you can. And that is the tool grep. So grep is kind of a funny name, but it actually stands for General Regular Expression Pipeline, but there are other names for it. But basically, what it is a way to search through files, and so there's various functions of it that I can use. Most basic grep is it takes some output and returns a match. And so basically, what happens is I could take let me jump back here to another folder that I was in, and we'll look at a file. And well, for example, let's take some data. We'll go ahead and take our CPU info on the process file system, and we will pipe it through the program grep, and we will look for the text CPU. So what happened is that that program gave me every line that had a match on it with the characters C, P, and U. Now, if I were to do something very similar to that, and I were to use the word cores, now I just get the lines with the word cores on it. Now, this can come in handy, especially if I know specifically what I want out of a file. Now, this could be a very long file. So, um, what we'll do is here is we'll use this. This is the word list, and that I have inside this folder. And notice it's Rockyou .txt. That's a huge word list that's used in cybersecurity circles. So what I can do is, and notice that the thing is actually zipped up. It's compressed. It's a really big file. I think it's like 53 megabytes or something. So if I were to look at that, and also we have symbolic links data right here. And if we look at all the symbolic links, um, the links are actually linked into specific files on the system. But in this case, the Rockyou word list is right there. It's really big. We can look at it and look at it in a human readable form, and we can see it's 51 megabytes size. That's the compressed size. So if I were to uncompress it, it would probably be very large. So one of the things that I can do is I can use a function of the grep program called ZGrep, which will search a compressed archive. And we're going to just search for the words that contain the word car. Now this is a very general um, regular expression. What I'm going to do through this is I'm going to look through the whole file, and I'm going to give you all the lines that contain the word car. Now, there are a lot of lines in this file. We could actually figure that out real quick by taking that file, and we're going to send it out to word count, and we're going to look at the number of lines in the file. So it looks like there are 14,344,392 lines in that file. Each line represents a word that could be used or has been used in a password at some point in time. So in this case, what we'll do is I want to go through and just see how fast grep is, okay? So I'm going to use the um, very simple, I don't, and I don't want to uncompress this file. I just want to use it compressed. So I'm going to use ZGrep, and I'm going to look for words that contain the word car. Now, that word car can be anywhere in that word list. Okay. Now, what the process that's taken so long is actually the process of writing the characters to the terminal. When I just process them without sending the output, it doesn't take very long. Notice it counted all the files. But also notice that this car word is anywhere in this list. It could be the beginning, it could be the end, it could be the middle, there could be some other character there. So just by itself, searching on the text container is not necessarily efficient. We can go ahead and see how many matches it found. It found 75,627 out of 14 million. Now, what I can do is I can use this idea of a regular expression, and I can use the switch B to tell it I'm going to use a basic regular expression. So it's not all that complicated. And I can do some special things. I can use some wildcard characters. And what I might want to do is actually search for just the word car at the beginning of the string. And I use that caret symbol to do that. And so I'm going to see how many times that happens. And that's 37,197 times when car ends up at the beginning. And then we can look and see how many words we have where there is one character in front of car. (4,138), and that's at the beginning. Two characters before car, 8,977. So that gives us just some information, right? If I went and looked that up, obviously the more specific I get, the less options I have. So I'm going to see how many people have the password of pass at the beginning. 5,911. If I put in a W, it drops. If I put in an O, it gets even less. There's still 2,368 of those. Now, what grep will tell me specifically is the line number that this is on. So if I wanted to find this specific place in the file, I could look at just that line number, right, and find that line. So these are examples of how grep returns the data. So we can use regular expression. Now, regular expressions can be very easy. They can be very complex. This is an example of a very easy one. I can match characters multiple times. I can match repeating characters, duplicate characters, the classes of characters. So what happens is every time I put a character in for a regular expression, it's called an atom, or it's the smallest unit that can match. So if I were to put in, say, a character like an asterisk, right here, and I wanted that to be at the beginning. And I wanted it to follow by a space. There are actually some of those. In that case, only 4. So in that particular case, I processed the whole file, all 14 million lines, in just a second, and returned the 4 results that were given me with that matching that pattern. So what you can see is that grep has a lot of power to it. It can do a lot of searching in a really short amount of time, and the more complex searches that I do, the better data I can get out of it. But I have to formulate that and make sure I know exactly what I'm looking for, and also understand that there could be situations where there are things that don't match my filter for some reason or another. So the regular expressions can be very powerful, but they can also be tricky. So grep is one of the best things that I can do with grep is to process log files. When I look for particular pieces of information, I can process a log file. And another thing that I'm going to do is I'm going to go back to my temp folder, and I'm going to make a symbolic link. It'll be a perfect example of why I might want to do that. So right here I have a Rockyou word list. It's buried into user share word list folder, and I know that I want to go back to my temporary folder that I like to work in. And so what I'm going to do is I'm going to make a symbolic link right here, and I'm just going to call it Rockyou. And so now I don't have to worry about if I wanted to actually output some results of the grep command and make some lists and some other things, I could do it. I have a symbolic link to my word list. I don't have to remember where it is, so I can just do ZGrep here, and I'm going to use a regular expression, and it's going to be any character at the beginning followed by the word hello. And I'm going to use Rockyou as my source file. And as you can see, I got plenty of those. Now I could actually send that right over to a file called hello. And now I have a subset of my word list matching. I could use that as input to a script or anything I wanted very easily. And as you can see, if I go and look at that in the VI editor, I have sometimes I have actually what I actually have in this output is I have some things I might want to filter out, like um, this first column of numbers followed by a colon. All right, so that would be an example of using the translate command to delete those characters out and get just the words that I wanted to find. So hope you enjoyed this example of grep, zgrep, symbolic links, and selecting subsets of word lists, including using regular expressions.